The deafening explosion echoed through the valley, followed by the sickening sound of collapsing earth. In seconds, the main entrance to the Silver Peak mine vanished, trapping 57 miners underground with oxygen reserved for just 12 hours. Cold morning mist hung over the remote Colorado mountains as emergency vehicles converged on the mine. The catastrophic tunnel collapse had severed all main ventilation and communication systems. Mining supervisor Frank Holloway stood ashen-faced before county officials and first responders. The structural integrity is compromised along the main shaft. Standard rescue equipment is at least 36 hours out, the county emergency director announced. The geological instability makes immediate excavation too dangerous. A ranger approached the growing crowd. There's a veterans wilderness training camp 10 miles east. Their leader has underground experience, former military. Minutes later, a mud-splattered pickup truck arrived. Jack Levins stepped out, his weathered face remaining composed as he surveyed the scene. At 42, the retired Navy SEAL combat engineer carried himself with the quiet confidence of someone who had faced worse situations. "What's the situation?" Jack asked, already scanning the mine entrance and surrounding terrain with practiced eyes. As Holloway explained the crisis, Jack's mind raced through similar scenarios from his military past. The miners' families watched from behind police tape, their faces etched with desperation. A woman clutched a photo of her husband while two young children clung to her legs. Jack nodded, his decision made before being asked. "My team and I can help. We got specialized equipment and training for this kind of situation." Jack moved with methodical precision, examining structural diagrams of the mine while his team unloaded equipment from their trucks. Unlike the anxious movements of others at the scene, his actions were deliberate, economical. This primary collapse triggered microseismic activity throughout the main shaft, Jack explained, pointing to the blueprint. These secondary structural failures have likely created air pockets, but they're also blocking standard rescue paths. Using a tactical flashlight, Jack examined debris samples from the entrance. There's evidence of methane buildup. The ventilation system failure means we're looking at toxic gas accumulation in the lower chambers. The county rescue coordinator looked grim. Our initial estimate of 12 hours of breathable air might be optimistic. With the methane readings we're getting, it could be down to 8 hours. Standard drilling protocols would take too long, Jack assessed. And with this shale composition, a direct excavation would trigger further collapses. We need to think differently. Jack closed his eyes briefly, memory transporting him to Fallujah, 2007. His unit had faced a collapsed bunker with trapped personnel inside. The parallels were striking. Unstable structure, limited air, conventional approaches too slow. "I won't lose them," he murmured, too quietly for others to hear. Opening his eyes, Jack gathered his team of 4 veterans from the Wilderness Training Program. "Remember our confined space extraction protocols from Baghdad? We're going to adapt them." Jack inventoried available resources. Local construction equipment, his team's wilderness survival gear, abandoned mining equipment, and emergency medical supplies. His mind cataloged each item not for its intended purpose, but for its potential application. "The mine has these auxiliary ventilation shafts," he said, pointing to narrow tubes on the blueprint. "Too small for human passage, but perfect for our approach." The mining engineer shook his head. "Those are outdated and weren't maintained. They could be collapsed too." "We can test structural integrity using acoustic sounding," Jack replied, "something we developed for cave systems in Afghanistan." Using a modified stethoscope connected to sensitive recording equipment, Jack and his team mapped vibration patterns along the hillside, identifying intact sections of the auxiliary system. "There's more," Jack continued, energy building in his voice. "These shafts form a natural network. Instead of one large rescue tunnel, which would take too long, we create multiple smaller connections, a redundant system." The local rescue team looked skeptical. "That's not standard procedure." "In SEAL operations, when standard procedures fail, we innovate," Jack replied calmly. "Each small shaft requires less structural support, can be established faster, and if one fails, the others remain viable." Jack pulled out his tactical notepad and sketched rapidly. "We'll need these materials," he said, listing equipment. And I need to establish communication with the miners to coordinate from their end. As his team mobilized, Jack paused, looking at the family members gathered beyond the police line. A young boy clutched his mother's hand, eyes fixed on the collapsed mine entrance. "Time's our enemy," Jack told his team quietly. "Let's move." Jack's mind flashed back to BUD/S training, the Navy SEAL's notoriously brutal qualification course. Instructor Ramirez's voice echoed clearly. Underground emergency ventilation isn't about the size of the channel, but the efficiency of the system. Multiple redundant pathways always beat a single point of failure. His team had spent 3 days in flooded tunnels learning those principles. Now those lessons would save lives. "We'll implement a cellular ventilation approach," Jack announced to the assembled rescue team. "Instead of one large shaft, we'll drill multiple 4-inch diameter holes in this pattern." He sketched a honeycomb design on the site map. The mining engineer frowned. "That's not how mine rescues are typically conducted." "This isn't typical," Jack replied. "In combat zones, we use this method to ventilate compromised structures while maintaining structural integrity. The honeycomb pattern distributes pressure and prevents secondary collapses." Jack demonstrated the pressure testing technique developed for SEAL infiltrations of structurally compromised buildings. Using sensitive barometric equipment from his team's gear, he tested rock density and stability at each proposed drilling site. "These readings show stable sections where we can safely drill," he explained. "The pattern creates natural reinforcement, like a geodesic dome." Jack assembled 5 drilling teams, each led by one of his veterans who understood the concept. He converted standard drilling equipment with specialized bits from his team's gear, originally designed for silent entries, into hardened structures during hostage situations. The vibration signature is 70% lower than standard drills, Jack explained to the county rescue director. Less vibration means less risk of secondary collapses. While the drilling began, Jack adapted military field communication equipment to establish contact with the trapped miners. Using a specialized low-frequency transmitter that could penetrate dense rock, they detected faint tapping from within. The miners were alive and responding to signals. Through a narrow initial hole, Jack lowered a modified tactical communication device. "This is Jack Levins, former Navy SEAL. We're working on a rescue system. Can you hear me?" Static crackled, then a weak voice responded. "We hear you. Air's getting thin. Some men are showing signs of hypoxia." "Understood. We're establishing multiple air channels. I need someone with engineering experience to help coordinate from your end." An older miner named Rodriguez took charge below, following Jack's instructions to position miners near the planned ventilation points and away from unstable sections that Jack identified based on his structural analysis. Jack converted emergency oxygen tanks into a pressurized delivery system. In desert operations, we use similar systems to clear sandstorm block ventilation shafts, he explained while assembling the components. The pressure differential will help draw out the methane while pushing in oxygen. For hours into the operation, they successfully established 7 small ventilation channels. Oxygen levels in the mine began to stabilize. The miners reported immediate relief, but the rescue wasn't complete. They still needed extraction paths. "Phase 2, Jack announced. "We'll expand 3 of these channels to create access points for emergency personnel and eventual extraction." Using principles from SEAL confined space rescue protocols, Jack designed a custom shoring system from available materials. The modular support framework could be assembled in sections and fed to the widening channels, then expanded from inside to create stable passage. This interlocking support system distributes weight loads similar to how we'd secure compromised urban structures during extraction operations, Jack demonstrated, connecting the lightweight but incredibly strong composite materials his team normally used for wilderness rescue training. As the expanded channels progressed, Jack continuously monitored structure integrity using techniques developed for covert tunnel operations. His veteran team worked with mechanical precision, their military training evident in their efficient movements and clear communication. County officials watched in amazement as the unorthodox rescue system took shape, proving more effective than conventional approaches would have been under the circumstances. 8 hours into the operation, disaster nearly struck. As they expanded the main extraction channel, A secondary collapse sent vibrations through the system. Sensors showed critical blockage in the primary air supply channel, with oxygen levels in the miner's main chamber dropping rapidly. The support structure is compromised in Section 3, reported Mike, one of Jack's veteran team members. We can't clear it from this end without risking complete failure. The rescue team fell silent. The nearest specialized equipment was still hours away. Jack studied the structural diagram, his expression unchanging despite the gravity of the situation. There's only one option. I need to go in through Channel 2 and clear the blockage manually. That's a 20-inch diameter passage, the mining engineer protested, and highly unstable now. I've navigated tighter spaces, Jack replied calmly, already removing his outer gear. In Fallujah, we extracted a wounded Marine through an 18-inch drainage pipe under enemy fire. Jack selected minimal equipment, a tactical light, communication device, specialized multi-tool, and a compact oxygen supply. As he prepared to enter the narrow passage, he caught the eye of a young boy he'd noticed earlier, still watching with his mother. "Tell Rodriguez I'm coming in to clear the blockage," Jack instructed his team. "I'll need his guidance from the inside." The passage was barely wide enough for Jack's shoulders. Using SEAL confined space movement techniques, he progressed inch by inch, controlling his breathing to minimize oxygen consumption, skills honed during underwater cave infiltration training. 200 feet in, Jack encountered the collapse, a section where support materials had failed, creating a critical blockage in the ventilation system. The space was now barely 15 inches wide, with unstable rock threatening further collapse. "I can see the problem," Jack reported through his communication device. The primary support bracket failed, and the secondary is compromised. In the operations area above, Jack's team and the rescue personnel listened tensely as he worked in the confined space. The miner's oxygen levels continued to drop. Jack's training took over completely. In the cramped darkness, he methodically employed techniques developed for underwater structural repairs, working by touch more than sight, using muscle memory honed through thousands of practice repetitions. In SEAL training, they called this working blind, Jack muttered to himself, manipulating the specialized tools in the tight space. Focus on the task, not the environment. The confined space grew hotter, sweat dripping into his eyes. A small shift in the rock sent debris down on him, but Jack remained focused, his heart rate barely elevated despite the danger, a physiological control mastered during SEAL training. After 27 minutes of precise work, Jack secured the compromised section and cleared the blockage. Immediately, sensors showed airflow resuming to the miner's chamber. Ventilation restored. Came Rodriguez's relieved voice over the communication system. "Whatever you did worked. Oxygen levels rising." Jack began the painstaking journey back through the narrow passage. Halfway through, a section behind him partially collapsed, trapping his leg. Using techniques developed for escaping entrapment during hostage extraction operations, he methodically freed himself without causing further structural damage. When Jack finally emerged, covered in dust and sweat, but otherwise unharmed, the rescue teams erupted in applause. The first group of miners was already being helped through the wider extraction channels his team had established. "How did you know that would work?" asked an amazed county official. Jack watched as a miner reunited with his waiting family, including the young boy he'd noticed earlier. "Because that's what we trained for," he replied simply. "Different environment, same principles." As dawn broke over the mountains, the last of the 57 miners emerged from the extraction channels. Medical teams evaluated each one, finding remarkably few serious injuries given the ordeal. The professional rescue equipment, originally expected to take 36 hours to arrive, was just pulling into the site as the rescue concluded. Jack stood apart from the celebrations, quietly packing his equipment. A mining company executive approached, hand extended. "That was the most innovative rescue approach I've ever witnessed. Your system saved everyone with hours to spare before our standard equipment even arrived." Jack shook his hand firmly. "My team deserved the credit. We just applied principles we learned in the SEALs." The miners did the hard part, staying calm and following instructions under extreme stress. News crews descended on the scene, cameras focusing on the dramatic reunion of families. When reporters turned to Jack for interviews, he deflected attention to the local first responders and his veteran team members. "How does it feel to be a hero?" one persistent reporter asked. Jack's expression remained serious. "In the military, we don't use that word lightly. We completed the mission. That's all. The real heroes are the people who do this rescue work every day." Later, as Jack's team prepared to leave, Rodriguez, the miner who had coordinated from below, approached with several others. "You military types," Rodriguez said, voice thick with emotion. "They trained you to never give up, didn't they?" Jack nodded. "That's the foundation of everything we do. When others might see an impossible situation, we see a problem that hasn't been solved yet." The Mine Safety Administration director arrived on site, requesting detailed documentation of Jack's cellular ventilation approach. This technique could revolutionize mine rescue protocols nationwide. Would you consider consulting on implementing this as standard procedure? This incident reminds us that the skills veterans develop during military service represent an invaluable resource in our communities. While we often think of military training in the context of warfare, the same problem-solving abilities, calm under pressure, and innovative thinking can save lives in civilian crises. As Jack drove away, he reflected on how military service prepares individuals not just for combat, but for any challenge life might present. The discipline, teamwork, and refusal to accept defeat become part of their character, qualities that benefit society long after uniforms are put away. Have you ever witnessed someone using skills from their professional background in an unexpected way during an emergency? Or perhaps you know veterans in your community who continue to serve in different capacities. Share your stories in the comments below. If this account of military ingenuity and determination inspired you, give a thumbs up and subscribe for more remarkable stories of courage and service that remind us of the extraordinary people living among us every day.